Hello everyone, today I would like to share my final project, which topic is about GPU performance analysis. So let's take an overview of our data set. So nowadays, modern GPUs play a key role in gaming, machine learning, and scientific computing. So I use a Kaggle data set of over 2,300 GPUs. This project applies multiple regression, one-way ANOVA and two-way ANOVA to analyze these relationships. So in conclusion, the results suggest that both hardware specifications and generational advances are major drivers of GPU performance and value. These findings provide useful guidance for GPU selections and system design. This is the summary of our dataset. The project main goals is what hardware features predict 3D performance. Do desktop, mobile, and workstation GPUs differ in power, performance, efficiency? How do device type and release error affect value for money? The first step is about data cleaning and derived variables. I created the device type from category, created error variable from test date, complete case filtering for different models. The code is here. And the second part is regression. For the regression, the response variable is 3CD mark and the 3D performance score. Predictors include G2D mark, TDP, release year, and price. After removing missing values, the regression uses 387 GPUs. The code is here, and the result is shown in the picture. The diagnosis of the regressions is the model performed very well, explaining about 85% of the variance in 3D performance, and all predictors were statistically significant. The next part is one-way ANOVA. For the one-way ANOVA, I compared the performance per watt across desktop, mobile, and workstation GPUs. The ANOVA results were significant. Mobile GPUs have the highest power performance ratio. Turkey test shows that mobile is significantly better than both desktop and workstation, while desktop and workstation do not differ significantly. The result of the code is shown in the picture, and this is the box plot. So this box plot makes the differences clear. Mobile GPUs cluster at much higher efficiency levels, while desktop and workstation GPUs overlapped heavily. The effect size is about 5%, which is modest but meaningful. Then we will talk about the two-way ANOVA. The response is GPU value, a performance per dollar metric. Factors are device type and release error. The result shows that error has a very strong effect. Newer GPUs provide much better value. Device type is not significant at the 0.05 level. The interactions is also not significant. This is the result. So the next part is interaction plot. The interaction plot shows nearly parallel lines. In other words, generation, not device type, is the main factor driving value improvements. So the key insight of the project is hardware features and release years strongly predict performance. Mobile GPUs are the most energy efficient. GPU value has improved consistently over time. Device type does not substantially change the generational trend. And to summarize, this project used regression and ANOVA-based methods to analyze GPU performance from multiple perspectives. The result shows that hardware characteristics such as 2D performance, power consumption, and release year strongly predict 3D performance. Efficiency analysis revealed that mobile GPUs deliver significantly higher performance per watt than desktop and workstation. Furthermore, GPU value for money has improved dramatically across technological areas, benefiting both desktop and mobile devices in similar ways. Thank you for listening.